What's up, solderers? So, we've already started doing our soldering on our circuit. We've done our first solder, and to this video we're just going to go through doing soldering the rest of the circuit. I have a screen that we're going to change later that's going to show the process of us going through the soldering. So if you want to see the soldering of an individual component, you can skip through the video and see that icon to show where we're soldering. So this is probably one of the longer videos that we're going to have. When it comes to you soldering in your home environment, whatever, get yourself in a nice relaxed position, good chair space, make sure there's good cross ventilation, good lighting, put on some sort of music if you want to help you focus. Me personally, I would highly recommend the Gandalf Head Nod 10-hour collection. It's what I like to do when I'm soldering my whole time, but I will turn the sound off for this video so you can choose your own music if you have lesser quality of music choices. Okay, so I am going to do a screen change now. Let's do this. Oh, there we go. So yes, this. So funny story. This actual camera up the top is a Logitech. Camera. It's like $200 and it's a nice high quality camera with a great autofocusing feature. The issue is if I was to put this camera up here close to my circuit, the autofocusing would not like it doesn't like doing macro stuff because it's going to be most of the time out of focus. This $10 camera that I got from AliExpress, we see it has I like to call it potato quality resolution, but it does have a manual focus, so I can force the focus up. I can force the focus to be locked in onto a particular depth of the circuit here, and so then I can continue soldering the whole circuit. So this is going to be one of our lower quality videos with this at the top, but I think that's going to give us some more overall. It's going to give us more overall value when looking at how to solder this circuit. Just align it up here. Let me get that focusing. Nope, a bit more this way. That's probably as good as we're going to get. And we've got a lovely angle. Good. Okay, so we had our first solder over here right now. As we can see, in the where's my screen? Over there at the top, I worked out a way to get an Excel spreadsheet loading up, and so we've obviously done our setup and safety so far. So done, tick. We'll move on to the next one. We're doing our 10K resistors, and so that chart over there in the top is going to change depending on what part of the circuit we're up to. So you can skip through the video if you want to see an exact component and how we do it, and hopefully if I'm on the ball I'm going to adjust all those correctly. Right, let me just move my mouse out of the way, and so we're going to be soldering again. We're always just putting our solder onto the point there for 3 seconds. 1, 2, 3. And we keep doing that. We see there's fumes. You can see them on the top camera over there. There's fumes coming up out from the soldering iron. I want to periodically be just slowly exhaling because I don't want those fumes to go into my face constantly. Yeah, we just want to like do a slow, gradual exhale. So these are my solders for my first pieces. I think they're functionality, they're probably fine. I probably still put too much solder into a lot of areas, so I'm going to try to improve my soldering technique and put less soldering into it. If we look at the other side of the circuit, over there we see a nice bunch of resistors. Okay, let's put in our next component. Let's put in our 470 ohm resistors. We'll take those off. We're just going to bend them. Slide them in. Alright, we have our resistors in. They're all lined up. Now let's flip over the board. So this is what we're trying to do the process here. As you see the list that I have there, I have them in the order that I want to solder them, and I'm putting in the resistors first because they're like the flattest component. But then next, oh, let me update that sheet. I said I would do that. Boom! Oh, look at that, top level production quality. I'm gonna get so many subs on YouTube for this. Too much solder on that one. Ooh, that's a good one. Or at least I think it's good. As you do more soldering, you're going to get more and more confident in your abilities to solder, which, you know, that's good. And so you're going to be going through and you'll learn exactly how fast you have to do certain components. Excuse me just rummaging through my areas. I'm looking for my clippers so I can actually start clipping and finishing these drawings. Sorry, these cuts. Got him. Alright. So we have our things here. Now, when it comes to clipping your components, right, there's pros and cons to clipping the end of your component, so clipping and finishing off your components now versus finishing them off later or at the end of your job. The advantage of doing them now, at the beginning, is when you're soldering other parts of your components, you don't have these big legs that are in the way. Right, so that's good, especially when you have like very intricate details. Like if we had like an IC chip with a lot of components very close to each other, we would want to clip our components and do that. So especially when we have like these big long legs coming out, especially with resistors, because we like to put our resistors as close to the circuit board as possible. The disadvantage of cutting them as we're using them is, let's do an example of like when we do these transistors. Right, when we do these transistors, when we saw in our video when we were placing them, how we have to wiggle them into place, right? And we have to like not force them. We have to sort of force them in, but we have to like be careful with how we're doing that. If we clip these at the wrong time, it's going to give us limited abilities to readjust them. The same thing with our LED lights. We said how sometimes you want to have room. We want to adjust the height of our LED light to fit like an enclosure, so it hits on the wall. Or if we have access to like switches or other stuff like that, we might want to adjust the maximum height. And so some components you'll want to clip them as you're finishing them, to seeing how they fit into a final situation. An example for like a capacitor: when you have your normal capacitor, right, you can have your capacitor flush up against the component, which means that it's going to be standing upright. Or sometimes you might want to bend the capacitor and have it like lying down flat. Right, so as opposed, you can sometimes have your capacitor. you can sometimes have your capacitor up against a component like this, or sometimes you might want to lie it down flat, like by bending it, and you'll need to like desolder and lift up your capacitor a bit so you can have access to bend it. So you might need that extra length. So you'll have to make a choice of which components you'd want to cut them earlier. Also, if you have to replace a component because you solder it badly, having a longer leg will give you more areas for you to like, let's say this area, this point that I'm joining over here. Let's say I ruin this solder over here and it disconnects. I can still attach the resistor to the circuit by getting the long leg over here and soldering this leg to another part of the circuit. Now, that being said, I've already inspected all my individual parts here, all my resistors, and I believe they're all of good quality, and I know that the resistors are the most resilient part of a circuit. In fact, they're the parts that are able to handle the most heat because literally their job is just to heat up, to convert electrical energy into heat. And they're also one of the components that have the longest legs, and if something was bad to happen and we have to replace a resistor, they're also one of the cheapest components to replace. So I am okay with cutting the legs of my resistors off right now, but and I might cut off the legs of my capacitors, but I'm going to save the legs of my LED lights and my transistors until I've tested my circuit. So I'm going to save those ones to cut at the very, very end for help me to do troubleshooting. But for these, I'm going to cut these off. When it comes to cutting them off, I would aim for about 1 millimeter above the solder, because you do not want to cut the solder, because if you put remember that we've heated up the copper and the glue underneath it. And so as we do that, if we put extra force on it with our cutting implements, the glue might not have fully solidified again, and we don't want to put, again, that unnecessary force onto our components. So let's just do 1 millimeter up, and depending on the type of cutters you have, you can use, I'm pretty sure you can use, most scissors could be used for this, especially the resistors, because they're very, very thin resistors. But use whatever you want, something that definitely cuts the metal and doesn't force it to be moved. So some older scissors or some lower quality scissors might like buckle around the component, and then if that's the case, you're going to have to find another method to cut your components. You not just buy any place where you buy your solder or your soldering iron should have these, which is just what are they, pliers or cable cutters? They will sell those as well. In a pinch, I've known to use toenail clippers to do this. But again, since this involves like lead and other components like that, I'd made sure that it was an old toenail clipper, one that wasn't sharp enough to do toes anymore. Or nail clippers, one that wasn't sharp enough to do that anymore. So instead of throwing it out, I've reused those several times to cut electrical components, also to cut like plastic components when I do my model making and stuff like that. You don't want to use a knife to do this because it's going to be very difficult for you to get the knife in the location. So you have all these feet over here that we're just going to put them. Going to put them over here. We don't want these to go on the floor because they're sharp pieces of metal, and if you step on them, you're going to cause issues. But so now we have a lovely row of resistors over here. And notice how I'm able to put this flat because I did cut those feet, so that's another convenience. Then when we flip over, see over here we have a nice job of a bunch of lovely soldered components. So with that, we finished our 4017s. Let's go on to the connector. So the connector goes here. Ooh, let me get that on the screen for you, please. The connector goes here. Right. It doesn't actually matter about its polarization because it itself isn't actually connecting to anything. When we put in our cables, we'll have to make sure that whatever our positive voltage source is going to connect to this. It's going to connect to this positive symbol over here, and the negative source will connect to this negative sign over here. So how I'm going to solder this, again, as we were saying about, it's good to have always solder by like the shortest components first. See how the connector is now the tallest component, so when I flip this board upside down, it's going to push down on this component, and to hold it into place. So let me go and flip this circuit over. You might have to get additional leverage from something if you want to do this all by yourself. Now there are devices that can hold your circuit in places. They have like clamps or something like that. If you have those, I mean, use it. If you have the means for like more advanced components, if you have like an air soldering iron, use that stuff. So this over here, as we have mentioned before, the connector is a very thick piece of metal. So with our soldering iron, we put 2 to 3 seconds. It's actually, sorry, with our resistors, the metal is very thin. So 2 to 3 seconds was enough to heat it up. 2 to 3 seconds might not be enough to heat up this component here. I'm going to have to judge it. I'm going to do it for 3 seconds. I'm going to put the solder near it and see if the solder is attaching to the metal component of the connector. If it's not, I'm going to let it heat up a bit more. I'm not going to adjust the temperature of my soldering iron because I believe 305 is enough for, sorry, 350 is enough for everything. I just got to give it more time to actually conduct the heat to the component. So let me attach it over here and I'll go 1, 2, 3. Yeah, it's not actually enough. See how it is attaching, see how it attached to the soldering iron itself and not the component. So I'm going to clean that off. So I know I need more than 3 seconds for this particular component because it's the thickest component we have. So go off. Alright, so let's go and let's give this thing more than 3 seconds. 1, 2, 3. Sorry, I'll do it this side so you can see it. 1, 2, 3. There we go. That took about 6 seconds. But we see now the rod is heated up to an adequate amount that it's accepting the solder. So that's good. We'll do the other one as well. It's hovering over the place. Let me see if I can get a better angle because I've got to put some downward force onto it, and it's a tad difficult with the orientation of the camera. Fortunately, I'm going to have to cover your view. Alright, so look, margin of error is going to be worse for this because we have to put more solder in and anything else. We have to heat it up more. So you see clearly I've used too much solder there. If I was running in a electronics factory in if I was an employee of an electronics factory in like a country that I'm not going to name, I would probably be fired right now for that waste of solder, but I'm not, so I can get away with it. It's all about the learning process there. The individual component, I didn't solder it perfectly. It's not aligned, but again, that's due to this part being fairly difficult to align up. I can potentially try to heat it up. I have to heat up both parts together. If I heat up both parts together, I might be able to, wrong way, I'm going to go this way. If I heat up both parts, I can align it so that looks right. Well, I think that's let's say it's about like 87 degrees. I think that's as close as I'm going to get. The most important thing is with this particular solder, see how these are two components that are very close and they use a lot of solder. This is a case where I could get a short circuit here, and this would be the worst case to get a short circuit because this is directly the positive and negative terminal. If I short circuit this, it's like me getting my battery or power supply and just connecting the wires together, and that's going to, if you're using a battery, it could blow up and destroy the battery. If you're using a power supply, it's going to activate its fuse mechanism, and it's just going to turn off directly. So that's a very important one. For us to see if there's a mistake. If you do have a mistake, you need your access to either a solder sucker or a solder wick to remove the solder. Did I plan ahead and get a solder sucker? I did. Alright, let's talk about, let's say if you make a mistake here. And actually no, I'll take that back. I'm going to do this right at the end. I'm going to make another video at the end to talk about the mistake. When we talk about like our, just before our final inspection and we do our testing. I'm going to show you there so we can skip to that video. So skip to the next video if you want to see how to use a solder sucker at any point to fix up any of your soldering errors. So what do I have next on the list? Next on the list we have the... Oop, I'm going to copy that. I've spent all the effort to get the tick, I want it. So next we're going to get the 301, the 9013. So as we've mentioned previously, the legs you have to slightly already extend them in order to fit through. Now, we know that through our stock take that V1 and V2 are the 9013s. So I have my legs over here, sticking them in place. I'm going to choose my height that I want to bring this piece down. Again, you don't want to force it, because if you force it and push it down too much, because the dots over here are wider than the actual the thickness of the legs at the base of the component, it will snap if you force it down too much. So I'd say about that height is enough. That is, if I had to guess, it's about 5mm from the base of the 5mm from the base of the component to the circuit board. It's also in a fairly position where I can hold it upside down and it's not bouncing around. And I'm just going to put that component in, and I'm going to solder these one at a time just to make it easier on myself. So these are standard size metal rods, so they should only take the 2 to 3 seconds for each one. 1, 2, 3. Ah, there we go. My boss would be proud for that one. Perfect. Now you see, as I could see it. I'm not sure about the replay. I'll have to look at it later on YouTube. But for those last two, as I was putting in the heat, we saw him putting in the solder, and then it just instantly, once the component gets to the right temperature, it almost like sucks in the solder towards it. So that's why I was putting in very little solder for those last two to see the actual way it was sucking the material in. And so we see there. Let me get you the lovely zoom. Okay, and let me get a pointing implement. So over here, these two over here. I'll go from the back. These two are probably the better solders. See how they use a very little amount of solder. This one uses a bit extra. Now, look, extra solder for an individual circuit doesn't actually, it's not the cost of the solder that matters. The issue, if you're putting in unnecessary amount of solder, you're putting unnecessary heat into the system. If you have a very, very heat sensitive component, you could cause a problem. But also, when you start to get components that are really, really close to each other, like these two parts over here, if they're really, or these two are probably the closest. When you have these two parts that are very, very close, when you're putting in excess solder, solder wants to attach to itself. And if you have two pieces with large of excess solder, it's likely to get that short circuit. So it's just, it's good practice to use the least amount of solder to get a very good joint connecting your system. Alright, so let me flip that over. We want to get V2. Now remember, the location has changed. The V1 had the angle. See how it's the flat parts have lined up. So when I do my V2, I want to do it in the other direction. So I'm just pre-widening. Can we see that? I'm just pre-widening my feet. Of my component. And then we're just sticking it in. And because we like stuff to look nice and neat, we're going to try to line it up to be the same height. And again, this component should be in and allow me to be ready to solder on the other side. And let's just get to that soldering, eh? And this is all the work we've done previously with the stock take is assisting us to do this really fast, because we know where all the individual components go. Look at that. That's like a speed run. I'm gonna get a timer for my next one. Like electronics teacher extraordinaire, Mr. Patain does a circuit speed run. Alright, so the last, so we've done that. Good. These, as I said, these are the components that I'm not going to clip. I will, however, see over here at the bottom, I'm seeing these two parts over here are very, very close. In fact, I think they're almost touching. So what I will do is I will grab myself. What am I going to grab myself? Ow. I grab grab myself some pliers. So these are pliers, they're other things, and I'm just going to make sure that these components over here are not touching, right? Just so when I do my testing, they're not going to cause any short circuit. I will later cut them, but like as I said, these components I like to test the entire circuit before I cut these individual components out, because they're going to be difficult to pull out, and they provide a significant structural support. Alright, so let me do my 8050 now. This obviously goes into V3. Again, I'm just scratching the legs. So let me update my chart. How are we going for time? 25 minutes. Ooh. So this is going to be one of the longer videos, so feel free to skip through the parts. You can solder most of the parts yourself. You can skip through to the next section if you're confident to solder them. I'm just going through all of them to give students an example to see an entire circuit being built. And, you know, sometimes I just like talking to myself. I don't have a classroom of students anymore to listen to me talk, so, you know, we all have our troubles. 3. Alright. Easy, fast, done. Nothing special with this. We have it in its right location. Alright, so whew, now we have the big job. We have all the LEDs. So now, as we already spoken, let's zoom in onto the front of an LED. We have an LED, and if we look at it, let me line it straight up. We see that there is that flat mark. For you, you're looking at it, it's the top of the LED. Right, the top of the LED clearly has a cut on it to represent that is where the negative terminal is, and that does line up. The flat cut does line up with the shorter leg of the LED, so we know these are correct LEDs. So does the order of the LED matters? No, the actual location in this particular one, they're all the same. But if we had like a there is a theory that if you can, we saw the circuit diagram and we saw that the number of the LED lights do relate to each one of these transistors. So let's say if you want to upgrade this circuit and put in multicolored lights, and so say this transistor is going to be related to all the yellow colored lights, this is going to be to all the green colored lights, and this will be connected to all the blue colored lights. You can do that. You just, in that case, you'll have to look at the circuit diagram and see which between V1, V2, V3, which LED lights correspond to that particular transistor, and then you could increase your color-coded lights. And it's a nice way to upgrade your circuit if you want multicolored lights. But I am going to start with where is L1? So we have L2, L3, L4, L5. Oh, L5 is there, so L1 is over here. Let's just, for the sake of consistency, let's just put in L1 over there. So let's just put in 1. I'm going to bring the LED down to the marking. So if, let me show you on a zoomed in piece. We see here this particular one has like a mark over there at the bottom. I'm going to line up my I'm going to line up my LED up to that mark right there. Hold on, right there. I'm going to line up my LED up to that mark, just so that way I know all my LEDs are up to the same height. So let's just do one LED for now, and then I'll put in the rest, and we'll go through that. So now we have our situation where like our height is going to be starting to be an issue, but it should be fine. These parts, like the LED light, the problem with the connectors that we had before is until it was soldered in, the connector did not want to stay in its position. It would fall out just because of like the size of the holes, and because you couldn't bend the prongs to like wedge itself in place. While the LEDs you can. So, and same with like our resistors. So that's not the biggest issue. Oh, that was not an ideal solder. All right. Second one looked a lot better than the first one. The first one I put in too much heat, And can we see any brown? We can see some over here. There is some black residue over here. So I put it in for so much that I actually burnt the flux, and we can see that black residue over there. So I put that in for too much, but everything else it should be fine. So I'm just going to go and I am not. I just said I would start with number one, but I'm not gonna. I'm not gonna do them in order. In fact, now I'm just gonna to speed run while I'm gonna put in all the LED lights into their correct location and their approximate right heights. Actually, I'm just gonna do half. Like some of these are not as solid into their location as I'd want. Alright, so flipping over, we'll just do half of the circuit at a time. Let me get it into the view there, so hopefully you see them all. Is that a view that works for you? Yeah, thanks for the feedback. And yes, I do realize that sometimes I'm talking to myself. Okay, so. Oh, that did not work, that one. Now, I know some of you might be wondering, did I complete this circuit and upload the episodes in like periodic order with the circuit already finished? And no, I am actually, as I'm doing the tutorials, and like I'm doing them in like pairs, for example, like this one was paired with the last tutorial. I am uploading them roughly as soon as it was like as soon as they've encoded and ready to record. Which means that I actually don't know, like as I'm uploading these things, I don't actually know if my circuit is working or going to work. So that's going to be real funny when we go to plug up the circuit and we see that if a mistake was happened all the way at the beginning that we can't fix. But you know, we're all human and it's all about learning. And then we get to do even more learning when we get to figure out how to fix mistakes that we've made. As Bob Ross has taught us all when it comes to life, there are no mistakes, there are just happy little accidents. Um, although Bob Ross has never had to remove a broken transistor because he overheated it on a circuit board, so, you know, take it with a grain of salt. Alright, speed run time. 1, 2. Oh, that's a bad one. You get to a point when you're soldering, right, where actually doing it as fast as as a fast, comfortable pace is actually better because you get into a habit of you're not actually putting the soldering iron onto the component for too long. So get into a habit of like if you get a nice momentum and you're able to do it fast, like I was doing there, yeah, you just tend to do it at a good pace and you won't overheat your component. So it's actually better in a way. Don't rush through it and remove the soldering iron before that's clearly heated up and gone around the component, but get yourself into a nice flow, and that's why I actually like setting up like 5 components because I can go bang, bang, bang. Well, not that fast, but I can go 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, and move along the components. Um, Again, obviously, I've had more experience with this, and so I'm more confident. But you will, as you increase your confidence value of soldering, you'll eventually get to that you'll eventually get to that world as well. Apparently the same is welding. Like my father loves his welding, and he said, like, he tells me when I started welding like a couple of years ago, he was so bad. It was just like just like to practice, and he says like now when he does it, he's able to like perfectly feed in the cables. It's the same thing. Soldering is the same thing. When you first start doing it, it's very very difficult, but then as you start soldering, you learn the natural speed of things, and you understand your soldering iron, and you're able to do that. Alright, so that looks like all my LED components are in. Let me just do a quick rotation so we can see it on the camera. A lot of shiny stuff. Yeah, sorry about I can't help the light reflecting, but so it looks like all those soldering components are in. We have some over there we can see on the screen. Where are you? Which one are you? This one? Yeah, we see there's a bit of see there's a black spot over here. Sometimes black spots are just because the flux has come out. But the important thing is there's no real evidence of burning on this. Possibly over here. We can't see that. And I don't even know if it's burning. I think it's just when it comes to overheating components, I think I'll put one down later. I'll deliberately ruin a component so you can see how to fix how to fix the common soldering problems. But I'm going to do that after I test my circuit, because there is a chance that I can actually damage a circuit beyond repair. So I'm going to do that. I'm going to do an episode of that after we've tested our circuit, just so. But have a look at the series when we get to the end of the series, where we'll talk about like how to fix our repair circuits. And oh look, we have 3 spare LEDs. So I might actually deliberately ruin one of the LEDs with the soldering and show like how to replace it. Some more difficult stuff, and we'll get to that later. So the last part of our circuit we have here, we have, excuse me, we have capacitors. Yes. So capacitors over here, white line with a negative. We have cables. When we flip over our circuit, we see here we have capacitor 1, 2. Now, as we can see, we're running out of real estate over here to actually see our components. But over here, we have C1, C2, and C3 relate to these. I can't go down anymore. Relate to these. So that over there is C1, below it is C2, and that down there is C3. When we're plugging in our capacitor, we just put in our legs. And we see over there, we're lining up the There you go. We are lining up the white part of our capacitor with the white part of on our circuit diagram. And I'm not going to push these all the way to the bottom. I'm just going to push it down to the height that they are comfortable. And I'm going to put in all 3 capacitors because they're all exactly the same for our circuit. So yay for us. My gosh, this has only been going for less than 40 minutes, so there's no reason why you can't do all the soldering in one single lesson. So here we see we're glad that it's really getting busy now for us to do this soldering. And it's even easier. It's easier that we removed out the resistors. These are the last parts we have to solder. If it is impossible to get to some areas, that's why we have to make like the decision of do we want to cut off the feet or the ended pieces of our of our components. But that's a choice that we can make. I think I can still fit my soldering iron in here. I'm just going to make sure I clean it. But I'm going to plan out my approach to this one. I am going to come in through here and get soldering through the other side. So I'm coming at more of a steep angle. Actually, if I do it this way, that might be easier. Oh yeah, that's it. That's the ticket. So again, I'm counting the 3 in my head. So because this is like just a standard component. 1, 2, 3. Oh, that one did not go well. We'll fix that. So that one I was too steep and I was attaching to the soldering iron and not the base, and I wasn't actually heating up the base. That's not a problem because we're going to cut that off anyway. You can see the soldering is clearly, in this one over here, you can see the soldering is clearly like on the component and not on the other board, so that's obviously not a completed soldering job. So let's see if I can just get an angle to heat up the, there we go. Much better. So the trick is you always, so just a summation, you always want to be heating up the copper, the circuit board and the component at the same time. You're actually not heating up the solder. Oh, that was another example. See, it's getting more difficult to do these because it's in harder locations. I'm not getting the ideal soldering iron connection. But so you want to heat up your component and the copper of the circuit board. And then those hot components is what's actually melting the solder in your ideal case. You're not melting the solder directly with the soldering iron. Ideally, you'd ideally want the circuit board and the electrical component to heat up to such a temperature that the solder so those are actually melting the solder, so the solder will attach to it. If you're putting your solder onto the soldering iron, it's your soldering iron that's actually absorbing the solder, and that's not always ideal. So let's go to the last part over here. Oop, that's incorrect. There we go. Let's look at our final inspection. So we're going to test it in the next episode, but as we're looking through, I don't see any. I'm going to look at it with my eyes first, and then I'll zoom it up to the camera. I don't see any issues. I don't see any parts that are short-circuiting. There's obviously. Let me go with my capacitor and change the screen to this size. So over here, clearly some soldering error. It's like holding up. Now that's not going to cause any problem with the circuit. I just got to, when I cut it, I want to make sure I cut it below there so I don't have that random piece of solder hanging out. I don't have any burn marks anywhere. I don't have any short circuits. So so far it all looks to a good level. So I'm going to end this video here, and in the next video we are going to trim the circuit. We're going to plug up the circuit to see if we can test it via power, and then we'll be finishing off our circuit. We're going to be like cutting some stuff shorter and to have a fully completed circuit, and then we'll do a lesson after that where we look at some errors. Well, I'll manufacture some errors, and we'll look at how to fix those errors and see if there's any troubleshooting we need to do. All right. See you all then.